So in these problems, we're asked to sketch some conics. So let's talk about what we need to do when we're sketching conics. First of all, you should recognize this as being an ellipse. It's positive x squared plus positive y squared, and these numbers on the bottom are different. So the first thing we have to do is plot the center. So the center is going to be at positive 3, positive 4. Okay, the x comes from the x stuff and the y comes from the y stuff. So 1, 2, 3, 1, 2, 3, 4. There's your center. Okay, now you have to do your major and minor axis. So in the x direction, we're going to go the square root of 16 or 4 units. Left and right. And in the y direction, we're going to go the square root of 9, which is 3 units. So we'll go 3 down and 3 up. And we'll connect these with as nice of a curvy curve as we possibly can. And the last thing to do is put in your foci. So your foci squared equals 16 minus 9. 16 minus 9 is 7. So the foci are square root of 7 units away from your center. So 1, 2.6, that's approximately, I didn't even think about a calculator. There's a focus here, and there's a focus there. Okay, for 34, hopefully you're recognizing this as being a parabola. It has one squared variable. So the vertex comes from the x part comma y part. So negative 4, positive 5 is where we'll find the vertex. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's your vertex. And now to figure out where the focus is. So 4p equals 8, this number here, which means that the focus is 2 units away from the vertex. Now the question is, which direction? Do we go up, down, left, or right? And we can tell by looking at the squared thing. Here we notice that the y is being squared, so that means this is going to open to the left or to the right, because y is squared. Okay, and because 8 is positive, this means it's going to open to the right. Left would be negative, so we go 2 units away to the right, and that's going to be where your focus is. Okay, so a couple other points. We want to figure out the distance of the lattice rectum, which is just 8 divided by 2 for your lattice rectum. So you go vertically 4 units, 1, 2, 3, 4. You go 4 units down, and the graph will go through these 3 points. Okay, through your vertex and through the 2 points of your lattice rectum. Okay, this distance here has to be the same as this number there. So it's evenly distributed because there are lots of symmetries with parabolas. Okay, this one we have a x squared minus 3 minus, okay, which means this is going to be a hyperbole. So we still have to do the center at positive 3, positive 4. And because it's a hyperbola, we need to make our box. So the box is going to go this square to this, left or right, because it's underneath the x. So we'll go 4 units to the left, and we'll go 4 units to the right. And then 9 will tell us we go vertically 3 units. And there we go. Now we make our rectangular rectangle. Okay, through your corners and the center go your two asymptotes. I know, graphing these things are tedious. So is driving to work every day. So let's see, x squared is positive, which means it will open along the x-axis. So here is one of your vertices, and here is another vertex. So it will swoop in here, and it will swoop out there. Here a swoop, there a swoop, everywhere a swoop swoop. Old hyperbole had a farm. Anyway, your foci is found by adding, not 16 squared, but adding your two denominators and taking the square roots. So our focus is going to be 5 units from your center, which puts it 1 unit outside of your vertex. Okay, now this is, of course, if it's x squared minus y squared. Now over here, notice we have a negative x squared. So even though everything about this graph is the same, we're going to have a hyperbola that opens vertically along the y-axis rather than along the x-axis. So everything else about this graph is the same as this graph as far as the boxes go, but now we're going to have a foci focus 5 units up here and down there. Because x squared is negative and y squared is positive, it opens along the y-axis. X squared is positive, it opens along the x-axis. Okay, now down here on 36, we're probably, the last one that we haven't done yet is a circle. Notice this is not in standard form. So we're going to have to put it in standard form by completing the square. So there I have my x stuff with a box. Now I don't have to do anything here because this is already a perfect square. Okay, this just factors to y plus 1 squared. So all I have to do is add one box over here, which matches up with that one. And the number that goes inside is half of negative 6 squared, which is positive 9. Then these things factor to x minus 3 equals 9. So my center is at positive 3, negative 1. And I have a radius of 3 units in every direction. So there's a little bit of review of how to complete the square in order to write one of these conics in standard form.